Hello everyone, today in this video I will be explaining the preparation of alcohols. Now alcohols are prepared by the following methods. Now the first method is from alkenes. Now how is alcohol prepared from alkenes? Now from alkenes we'll be having two types of preparation methods from alkenes. The first one is by acid catalyzed hydration reaction. Now in this reaction, alkenes react with water in the presence of acid as catalyst to form alcohols. Now, however, in the case of unsymmetrical alkenes, the addition reaction will take place in accordance with Markovnikov's rule. Now, so let's see how is the preparation of alcohols from alkenes takes place. From the definition we have here are alkenes. Let's take any alkene. General formula: alkenes react with water in the presence of an acid as catalyst to give us alcohols. This is the general reaction. Now, for example, we have here CH3, CH double bond, CH2 plus H2O. It is catalyzed by an acid to give us CH3, CH, CH3O, H. Now this is the preparation of our alkenes from alcohols. Now here it follows Markovnikov's rule in the case of unsymmetrical alkenes, that is, the negative part of the acting substance gets attached with the carbon atom having lesser number of hydrogen atoms. Thus our OH is attached here. Now let's check out the mechanism. Now the mechanism of the acid catalyzed hydration takes place in 3 steps. Now let's check out the first step. Step number 1 is protonation. Protonation of alkene by attack of H3O plus to form a carbocation. Now our water molecule is acid catalyzed, giving us H3O plus. Now here we have our alkene, carbon to carbon double bond. Our alkene is here, H. Let me open the structure. Now this double bond goes here. The bonding electron shifts to our OH minus. Therefore, we will be getting here our carbon to carbon. This hydrogen goes and bonds with this. This is the hydrogen, and then we have our carbocation. It loses the bonding electron pair, and then we will be getting here our H2O. Our H3O plus gets back its bonding electron there. Now, step 2. In the second step, it is the nucleophilic attack of water on carbocation. This is our carbocation. Now we have our carbocation. Now H2O. When the electron pair gives its electron, and then we'll be getting here our hydrogen is here, carbon to carbon, these 2 bonds, and then this OH goes and bonds here, OH. Now after this product has been formed, the third step will be the deprotonation to form alcohol. Means deprotonation means removal of proton from this. Therefore we have carbon, hydrogen, carbon single bond, OH. There's only one left. Now deprotonation from our H2O molecule. This one comes and takes away the hydrogen atom. The bonding electron shifts to our oxygen atom. Therefore, we will be getting here our alcohol, that is OH, along with the removal of again H3O plus ion. Therefore, this is the preparation of alkenes from alcohols when it is catalyzed, when it is an acid catalyzed hydration reaction, and it takes place in 3 steps. The first step is protonation of alkene by the attack of H3O plus to form a carbocation. Now the carbocation is attacked by water molecule to give us this, and then in the last step there will be deprotonation to form alcohol, means removal of a proton from this molecule. Therefore, this proton is removed, the bonding electron shifts here, and then we will be getting here our product. And therefore, this is our alcohol. Now the second method of preparation of alcohols from alkenes is by hydroboration oxidation method. Now in this method, diboron BH3 whole twice. Diboron reacts with alkenes. Diboron will react with our alkenes to give us dry alkyl boranes as addition product. Now, the addition product is oxidized to alcohol by hydrogen peroxide in the presence of aqueous sodium hydroxide. Now, let's check the reaction here. We have an alkene here, CH3, CH double bond hold, CH2. When it reacts with our diboron, it will give us dry alkyl boranes as addition products. Therefore, let's HBH2 whole twice, just exponents here. Now after this, we will be getting here the addition products here. The first one is CH3 CH2, and then here our BH2, the hydrogen atom gets attached here. Now, and it reacts with another molecule of alkene. It reacts with another molecule of alkene to give us here another addition product, CH3 CH2 CH2 whole twice BH. Now again it will react with the third molecule of our alkene to give us the third addition product, that is our CH3 CH2 CH2 whole twice BO. Now this is the addition dry alkyl boranes, the third addition product that we get when our diboron reacts with alkenes, 3 molecules of alkenes. Now this is oxidized by alcohol in the presence of our hydrogen peroxide. In the presence of our hydrogen peroxide, we'll be having a water, hydrogen H2O2, hydrogen peroxide, and it is oxidized to alcohol in the presence of hydrogen peroxide by hydrogen peroxide in the presence of our aqueous sodium hydroxide. So let me take OH minus. Now on oxidation, we'll be getting here our 3 molecules of CH3 CH2 CH2, 3 molecules of alcohol, and then BOH3. This is our propane 1O. Now the addition of boron to the double bond takes place in such a manner that our boron atom gets attached to the sp3 hybridized carbon atom having greater number of hydrogen atoms. This thus the alcohol so formed. It looks as if it has been formed by the addition of water to the alkene in a way which is quite opposite to that of Markovnikov-Schulze. Thus, in this type of reaction that happens by hydroboration oxidation method, the yield of alcohol is obtained in larger and in excellent yield. Now, the second preparation method of our alcohol is from carbonyl compounds. from carbonyl compounds. That is, the first one is our reduction of, number one is reduction of aldehydes and ketones. Now aldehydes and ketones are oxidized, aldehydes and ketones are reduced to corresponding alcohols by the addition of hydrogen in the presence of catalyst, that is our catalytic hydrogenation. Now here the usual catalyst that we use is finely divided metals such as platinum or palladium or nickel. Now here let's check here. Therefore, if aldehydes on reduction, addition of hydrogen in the presence of palladium, next is we'll be getting here our CrCH2 OH. And if our ketone is in the presence of sodium borohydride, then we'll be getting RCH OH. Therefore here this is the preparation of our alcohols from aldehydes and ketones. Here we are getting a primary alcohol. Here is a secondary alcohol. Now let's check the second one. The second one is reduction of carboxylic acid. Carboxylic acid and esters. Now carboxylic acids and esters. Now carboxylic acids are reduced to primary alcohols in excellent yields by lithium aluminium hydride, and which is a stronger carboxyl COOH. This is a common carboxylic acid. It is reduced to by lithium aluminium hydride is a very strong reducing agent, and we get there are CH2OH are alcohol in excellent yield. Now however, our lithium aluminium hydride is a very expensive reagent, and therefore it is used for preparing special chemicals only. Now the second one is from our esters, RCOOR-. Here we are using hydrogen in the presence of a catalyst, RCH2OH, along we will be getting here two molecules of different alcohols. Now the last preparation method of alcohols is from Grignard's reagent. Now in this reaction, alcohols are produced by the reaction. Okay, now from Grignard's reagent, now here it takes place in two steps. Now in the first step, it is the nucleophilic addition of our Grignard's reagent to the carbonyl group to form an addition product, and then in the second step, there is hydrolysis of the addition product yields our alcohol. Therefore, if we have our carbonyl compound, this, then when it reacts with our Grignard's reagent, RMGX. Now here because of minus I effect, the R group will pull the electron pair towards itself more and more, and then there is a partial negative charge here, a partial positive charge is created here. Now because of this, there is pull. This goes and takes nucleophilic attack of the Grignard reagent to the carbonyl carbon, and then this shifts here, and then therefore we will be getting the addition product here, carbon, R is attached here, oxygen gets a negative charge, MgX positive charge. This is the added or the addition product. Now this added addition product undergo hydrolysis to give us our alcohol H, and then our MgOH X will be removed. Now the overall reaction happens using different aldehydes and ketones. Now when we use only aldehydes, that is methanol or formaldehyde, when it reacts with our Grignard's reagent, it gives us the CH2OMGX. This is the addition product, and then when it undergoes hydrolysis, it will give us a primary CH2OH. It will give us a primary alcohol when we use methanol. Now if we use any other aldehydes except for methanol, other aldehydes, that is RCHO, when it breaks with our Grignard's reagent, it will give us the addition product is here. Undergoes hydrolysis to give us our secondary alcohol. Here in this region, we will see that only methanol gives us primary alcohols, aldehydes give us secondary alcohols, and ketones will give us tertiary alcohols. Therefore, this is the preparation method of alcohols.